Hello, my name is Selin Alara Ornek, and today I'm going to tell you about my robots and how I'm trying to use AI for good. By the way, I'm having a little bit of internet and electricity issues, so if I disconnect, I'll be back in a few seconds. First, I'd like to tell you a bit about myself. I'm 15 years old. I live in Istanbul, Turkey. I am in ninth grade at Irmak High School. I'm also a young member of New York Science Academy and a mentee in the Thousand Girls, Thousand Futures program. I love robots and I'm a maker. I love animals, traveling, reading books, and gaming. I speak English, Turkish, and French, and I'm learning Python, C++, and Java. In 2018, I won first place at the hardware category at Close Projects International. The same year, I was also a finalist at the European Youth Awards. In 2019, I was chosen the European Digital Girl of the Year at the ADA Awards. In 2019, I was featured as a dev kid in the Google Developers blog. And in 2020, I won the Microsoft Leaders in Technology Rising Star Award. The same year, I have been chosen as a Woman of the World, the Global Young Leader. And in 2021, I won first place in the open category at the Bosphorus Robot Cup. My biggest dream is to build a humanoid and to create a vehicle that can travel faster than light in space and send one of my humanoids to the black hole for research. A lot of people ask me how I got started. In 2014, I loved to play Minecraft, and I always wondered how it was made, and I then started coding with MIT Scratch. And in 2015, my dog Corsan died, and I was really sad, and I wanted to bring him back to life. We had a math project at school, and I had to speak to an engineer. While I was talking to him, I asked him how I can make a robot dog, and he told me to learn mechatronics. And in 2016, I started building with MBot, which combines Scratch and Arduino. Then I learned that with Arduino, I can make more advanced projects. So I decided to make Taco a smart color for dogs. And for me, the best way to learn is by doing so. So while I was making Taco, I learned Arduino and C++. And in 2018, for more advanced projects, I started to use Raspberry Pi and learn Python and building robots. I love dogs, so my first project was a smart color for dogs. My dog Bailey spends his day eating, sleeping, or pinching socks, but I love him in pieces, and I was really afraid of losing him, so I decided to make this color. IC4U, the robot guide dog for blind people. As I mentioned before, I love dogs, and when I was 8 years old, I lost my dog Corsan. He died, and I was really upset because he was like a brother to me. And then when I was on holiday with my family, I saw a guide dog and a blind person, and I thought that if he lost this dog, he would lose his eyes, he would lose his best friend and his eyes again. So I decided to build IC4U. Before I start to build my robots, I decide what features I would like to add. So before building IC4U, I got in touch with guide dog associations in both United States and United Kingdom, and I learned how they train, how they behave, and their relationship with the blind person. And a guide dog needs to obey the commands of the blind person. So the guide dog needs to adjust its speed and move in the right direction. They have a sense of location in the locations they have frequently visited, but they don't have this when they go to a new place. I also learned that guide dogs have a special ability called intelligent disobedience, which means that if they sense a dangerous situation or any obstacles, such as steps, a hole, fire, smoke, or something similar, they become disobedient and do not obey the blind person's commands. Instead, they take action accordingly and autonomously. I heard that sometimes a guide dog will not let the blind person cross the road even though the light is on green, because they feel vibration on the road and they can hear car noises approaching. I was fascinated by to add. I was fascinated by this feature, and I wanted to add it to my own robot, but it was a little too complicated for me and advanced, so I decided to add sensors instead. In version 1 of IC4U, IC4U can detect the situations with the help of sensors and warn the blind person. I also learned that blind people can use their mobile phones with voice voice features. I also saw this as an opportunity to integrate this feature by building an application to enable communication between the robot and the blind person. I also added a GPS shield so that the blind person and IC4U can be traced by the person's loved ones. IC4U and I won the first place in the hardware category at Schools Projects International 2018. I received my award from the founders of Raspberry Pi, Eben Upton and Pete Lomas. I was really happy and wanted to make a more advanced version, so I started to build IC4U too. If you remember, I spoke about intelligent disobedience and how I didn't have the skills, so I added sensors to the first version. However, I learned that if I moved on to Raspberry Pi and learned to code in Python, I would be able to use artificial intelligence in order to add features that are similar to those of the intelligent disobedience. In this version, instead of using a mobile application, with the help of Google Voice Chat and Google Assistant API, the blind person can give a command directly to the robot. IC4U can also now understand sit and stand down commands. I have to admit that building these joints with servos took nearly as much time as it to build the whole robot. This is the code which allows the blind person to give commands to IC4U. In this section of the code, Google Assistant is activated and waits for the user to say, OK Google. If the user says OK Google and the command, it runs the void and the code in the void with the following command. The code in the void starts with the following command. As I mentioned before, I had a lot of problems with the servos, and after a lot of research, I found out that Raspberry Pi prioritizes the process, some other process, and sometimes the servos can be pushed to the back. So as a solution, I decided to add an Arduino to the system and connect the servos to the Arduino. I made a serial connection between the Arduino and the Raspberry Pi and connected servos directly to the Arduino. As you see in the code, as you see in the Python code, Raspberry Pi sends a signal to the Arduino, and Arduino runs this code and IC4U lays down. I replaced the ultrasonic sensor with a camera. By doing this, I was able to add object recognition abilities to IC4U so that IC4U can now detect obstacles and dangerous situations. I used TensorFlow and OpenCV library and an MS Coco dataset for the object recognition. In order for IC4U not to get confused by all the objects and surroundings, I added this blue frame, and IC4U can now detect the objects within this frame. For example, if IC4U sees a stop sign, it warns the blind person that it has seen a stop sign and that it has stopped for the blind person's security. I have also added a conversation mode to IC4U by using Dialogflow. So with the help of Google Assistant API, the blind person can make conversations with IC4U. These are some of the phrases that I thought maybe the blind person would like to ask. I've trained IC4U to choose one of these responses randomly. I'm also developing this feature so I can train IC4U to respond to more phases. I must admit, training IC4U is a lot easier than training my own dog. Now I would like to show you a video of IC4U's artificial intelligence abilities.
Talk to IC4U. All right, let's for you. Woof woof. Hi, my name is IC4U2. I am your guide dog. How can I help you today? Tell me about yourself, please. My name is IC4U2. I am powered by Raspberry Pi and Arduino Mega. I was created by Selin Alara Ornek, also known as Selenoid.
Okay, Google. Go. Okay, Google. Stop.
I see a stop sign. I stop for security. There is a chair in our way. Let's go round it.
I'm currently working on integrating Google Maps to IC4U2. I managed to make IC4U2 to pull directions data from Google Maps and read them out loud to the blind person. I'm still working on IC4U2 to follow directions autonomously. Any recommendations at this point shall be appreciated. With the help of GPS and GPRS Shield and Google Maps API, I plan to make it possible for IC4U2 to navigate to the destination that the blind person has chosen on Google Maps. To do this, I also need to improve some features on IC4U2. I'd like to add sound sensors in order to improve its senses of the surroundings, such as car noises when crossing the road. I would like to change the hot word from OK Google to OK IC4U2 because it triggers all the assistant devices in this way. I would also like to add the LiDAR to support image recognition with dynamic 3D mapping of its surroundings. I believe that when all of these are complete, IC4U2 will behave intelligently disobedient, like a real guide dog with the help of artificial intelligence. IC4U has eyes that are little screens, and I also have plans for IC4 to show its feelings through those screens. First thing I'd like to do is for it to show hearts when it sees my mom. While working on IC4U2, I also built BB4All, a robot that helps teachers, students, and staff at school. BB4All has face recognition ability, so every morning it greets the children by name and asks how they are. If the student is to say that they are not very good that morning, it refers them to one of the teachers. BB4All also helps with any announcements that have to be made. As you know, teachers give a lot of homework, especially at the last minute, so BB4All is in charge of handing out all the homework. I also want to make a more advanced and stable version of BB4All, so I built BB4All version 2. BB4All's body is made of 3D printed parts, plyboards, and its legs is made by drain pipes. Its head is made by my mom's broken toaster, and the screen is a broken laptop screen. I used the microprocessors Raspberry Pi 4, Raspberry Pi Zero, and Arduino Uno. BB4All has all its screen eyes and a mouth made of RGB LEDs, so that it can show students their emotions. Its mouth is controlled by Arduino Uno, who is connected serially to the Raspberry Pi 4. For example, when BB4All hears negative words, BB4All's RGB LEDs turn red, and when BB4All hears positive words, the RGB LEDs turn green. OLED displays and Snake Eye Bonnet is powered by the Raspberry Pi Zero. BB4All can identify different lines of different colors. To do this, I use the line sensor and the color sensor together. These sensors are connected to the Raspberry Pi. 4 motors and mechanism wheels are connected to two motor drivers. The signal cables of the motor drivers are connected to the voice-at, while the VCC and the ground are directly connected to 12-volt battery. The webcam is connected to the Raspberry Pi 4 via USB, and all the laptop screen is connected to the Raspberry Pi 4 via graphic card and HDMI. I also designed a watch for students to wear. On this watch, there is an eye beacon, a pulse sensor, and an Arduino Nano. To code the Raspberry Pi, I used the coding language Python, and I'm going to tell you more about where and how I use these platforms in the next slides. BB4All will walk around the school corridors. When it sees a student, it will recognize them by their faces, thanks to the OpenCV and the LIP libraries, and use their name to grade them and ask them how they are feeling. Depending on the answer, BB4All will take different actions. If BB4All hears a keyword about the student not feeling well, BB4All directs the student to the counseling. I use Google Assistant API to do this. Thanks to the image processing feature, BB4All can detect the student's facial expressions such as unhappy, happy, or confused. It has also the feature of detecting how they are by getting triggers by students' facial expressions. I use TensorFlow to do this. Now I'd like to show you a video of BB4All.
Hi, Selin. How are you doing? Okay, Google.
I'm fine, thank you.
Great to hear. Hi, Alton. How are you doing? Okay, Google.
Not too good.
Sorry to hear that. Would you like to talk to someone?
According to UNICEF, in the world, 1 out of every 3 students between the age of 13 to 15 face bullying, and the same number of students are involved in physical fights. One of the main features of BB4All is to prevent bullying. As I mentioned before, I have also made a smartwatch. If the student's heart rate suddenly increases or they press the panic button, the iBeacon sends a signal to the gateways and that are placed inside the rooms. BB4All finds the room where the signal is activated and goes to the relevant room by following the lines with different codes of the rooms. As BB4All is equipped with face recognition, audio recording, and the ability to ask questions to the student that will analyze the situation, I believe that BB4All will be quite effective in preventing bullying. Another feature of BB4All is the ability to inform students privately and collectively. Thanks to this ability, it can deliver a message that is need to be delivered to the student through the screen and the sound system. The students can also chat with BB4All. Thanks to Google Assistant, students can ask questions and get answers, of course with a filter. I am currently working on uploading the database that's kept locally to the Firebase real-time database by applying the information I learned. So when I ask him about a grade, he can tell me about my grade.
Hi there, Selin looks busy working on a new robot. I am BB4All, a school aid robot, and I help prevent bullying. Selin also built 2 other robots for...
I've always wanted to use mechanical wheels, and since BB4All will be used indoors, I want to make the movement and the maneuverability to be more precise. So I used mechanical wheels. This way, BB4All dances better. And Hashmet the android. I first met Android at Google HQ in Dublin, then at Google Plex. As I really liked Android, I decided I want to build an Android robot. On Hashmet's head, there's a Google Assistant mini device, so Hashmet can tell you jokes. Hashmet also has face recognition and gives a special message. I'm a big fan of Star Wars, so I made Dio from the last Star Wars movie. This was my first robot that had one wheel. And my last project, Java. Java is a tracking system for stray dogs. In Turkey, a lot of dogs live in neighborhoods, and local people feed them, take care of them. During the pandemic, as a lot of local businesses are closed, and due to lockdown and curfews, they have had limited human interaction. This is a system that consists of a mobile app and a handheld device to track, trace, and register the dogs in the areas they belong to. I named it after Java, a stray dog in my neighborhood. I'm still learning and I learn something new every day. I'd like to thank all my mentors for helping me and supporting me. Thank you for listening to me. Please follow me on my social media accounts and don't forget to subscribe to my YouTube channel.